Hi friends, today I am giving a lecture on stacks in data structures. Before going to the stacks in data structure, first of all we know what is data structure and what are the types of data structure and what are the examples for each and every type of data structure. First of all, data structure is a particular way of storing and organizing the data in a computer so that it can be used efficiently. Generally, data structures are two types. First one is linear data structure. Second one is non-linear data structure. In linear data structure, the elements are logically organized in sequential manner. That is, the elements are logically organized in a sequential order. Examples for linear data structures are arrays, stacks, queues, and linked lists. Next one, second one, non-linear data structures. In non-linear data structures, the elements are organized in non-linear fashion. So the examples for non-linear data structures are trees and graphs. Okay. Now we go for stack. A stack is a linear data structure in which insertions and deletions that can be made on at one end, that end is called as top of the stack. So that means both insertion of elements into the stack and deletion of elements from the stack that can be made on one end, that end is called as top of the stack. Next one is stack works on a principle called principle of optimum. Stack works on a principle called LIFO. LIFO means last in, first out. What is the meaning of last in, first out? Suppose we are adding some elements into the stack. Okay, whatever the element that is inserted at the last, that element can be come out from the stack first. So that is called as last in, first out. So stack works on a principle called LIFO, last in, first out. That means whatever the element that is inserted at the last, that element is the first one to come out from the stack. So this is called as LIFO order, last in, first out order. Next one, suppose we have to take 6 elements. That elements are 10, 20, 30, 40, 50, 60. So this is a stack. Suppose initially the stack is empty. So stack is empty is nothing but top equal to 0. If top equal to 0 means there are no elements in the stack. Okay. Suppose we are inserting the first element, that is 10, into the stack. First we are incrementing the top. Then after that we are inserting the elements 10 into the stack. Next we are inserting second element into the stack. First we are incrementing the top, then we are inserting the element 20 into the stack. So then suppose we are inserting element 30 into the stack. So what are the steps we have to follow? First we are incrementing the top. After incrementing the top pointer, then we are inserting the elements into the stack. So in the same way, so 10, 20, 30, 40, 50 and 60, that we are inserting the elements into the stack. Finally, what is the element that is inserted at the last? That is 60. At the 60, so top pointer is points. Top pointer points to the only 60 element. Okay, so this is the element that is inserted at the last. So top pointer points to the element that is inserted at the last. So that is okay. So in the stack, 10 is the bottom element and the top element is the 60 element. Okay, suppose we are inserting the elements into the stack. What are the steps we have to follow? First step is incrementing the top, and the second step adding the element into the stack. These are the two steps we have to follow while inserting elements into the stack. Okay, next, what are the example for stack? The example for stack is a stack of coins. Okay, a coin is placed on one and another. Okay, suppose we are adding new coin into the stack. That coin is placed on the previous coin. Okay, suppose we are removing one coin from the stack. Okay, whatever the coin that is inserted at the last, that coin is removed from the stack first. Okay, so this example resembles the working of stack principle, that is last in first out. Next, what are the operations that can be performed on the stack? There are three types of operations that can be performed on the stack. First one is insert operation, second one is delete operation, third one is display operation. First one is insert operation. So to insert an element into the stack, we have to use one function, that function called as push function. So push function is used for inserting an element into the stack at the top. So what is the definition of push function is here void push int item. Okay, whatever the item that we want to insert, so that item can be passed as an parameter for the push function. Okay, so let's begin. First, to insert an element into the stack, first what is the task we have to do? Incrementing the top pointer. So that is top equal to top plus 1. After incrementing the pointer top, now whatever the element that we want to insert, that element is inserted at the top of the stack. Okay, now item is an element we want to insert at the top of the stack. So therefore stack of top is equal to item. This item is inserted at the top of the stack. Okay, so this is the definition of push function for inserting an element into the stack. Next, second one is delete operation. So delete operation is used for deleting an element from the top of the stack. So for that purpose, we have to use one function, that function called as pop function. So pop function is used for deleting an element from the top of the stack. Okay, the definition for pop function is, so int pop, brace begin, int item, whatever the element that we want to remove from the top of the stack, So that item can be defined. So item is equal to stack of top. Okay, whatever the item that we want from the top of the stack, so from the top of the stack we are deleting the element at the top. That element can be assigned to the item. Okay, so now decrementing the top pointer. After deleting an element at the top, now we are decrementing the pointer. Okay, so then finally return item. So whatever the item that we are removed from the top of the stack, that item is returned. So that item is an integer, so that here return type is int. Okay, so this is the definition of pop function to delete an element from the top of the stack. Next, third operation is display operation. This display function is used for displaying the elements in the stack. Display function is used for displaying the elements in the stack. For that purpose, we have to use one function. That function is called as display function. So void display brace begin. Here we are displaying the elements from the top to 0th element. So now we are starting at the top element. So for I is equal to top minus 1. Why we are using top minus 1? We are starting with 0. So that we are starting from I is equal to top minus 1 up to which element? Up to which elements we are displayed? Up to greater than or equal to 0. I greater than or equal to 0. Now we are decrementing one by one. So that is I minus minus. So printf percentage D stack of I. So stack of I. So this function is used for displaying the elements in the stack. Now we are observing some conditions. One is stack overflow condition. Second one is stack underflow condition. Third one is stack full condition. And fourth one is stack empty condition. Okay. So when we can say that stack is full. Okay. Suppose we are inserting elements into the stack by using push operation. If the top pointer reaches the maximum size of the array, so then again we are performing the push operation. Then we are getting stack and overflow condition. Then we are getting the stack overflow condition. Okay. So stack overflow means, suppose we are performing the top stack overflow condition. Suppose we are performing the push operation. Whenever the push operation is performed, top is incremented. If the top pointer reaches the maximum size of the array, okay, after reaching the maximum size of the array, again we are applying the push operation. Then we are getting the stack overflow condition. Next one, stack underflow condition. Suppose we are removing the elements from the top of the stack. After removing the element from the top of the stack, we are decrementing the top pointer. If the top pointer reaches the top equal to -1, again we are applying the pop operation. Then we are getting the stack underflow condition. Next, Third one is stack full condition. Okay. Suppose we are performing the push operation. Before performing the push operation, we are incrementing the top pointer. If the top pointer reaches the maximum size of the array, so then we can say that stack is full. Okay. Next one, stack is empty. Okay. Suppose there are some elements are there in the stack. Now we are performing the pop operation. Whenever the pop operation is performed, one element is removed from the top of the stack. So now top pointer is decremented. If the top pointer reaches the -1 value, so then we can say that stack is empty. Okay. When we can say that stack is overflow, when we can say that stack is underflow, when we can say that stack is full, when we can say that stack is empty. Okay. Next we go to the what are the applications of stack. Next one, what are the applications of stack? The first application is converting infix expression to postfix expression. Second one is converting infix expression to prefix expression. Third one is evaluating postfix expressions. And fourth one is recursion. So these are the 4 applications of stack. Next one, how to implement the stack. A stack can be implemented using 2 ways. First one is stack using arrays and the second one is stack using linked list. Okay, now we are observing this example. So now we have to take a stack with the size 4. Okay, so first we are performing the insert operation 4 times. Okay, so initially top equal to -1. Initially top equal to -1. First we are performing push of 10. Push of 10. First element is 10. Push of 10 means inserting 10 element into the stack. So therefore, after inserting the element into the stack, so then top is, before inserting the element 10 into the stack, first top can be incremented. So now top -1 is incremented to 0. So then the element 10 is inserted into the stack. Next one is push of 20. So before inserting element 20 into the stack, top can be incremented. So now top is equal to 1. So then we are inserting the element 20 into the stack. Next, third insert operation, that is a push of 30. So before inserting element 30 into the stack, first top can be incremented. So top equal to top plus 1. Now top is equal to 2. Okay. Now inserting element 30 into the stack. Okay. So now again inserting element 40 into the stack. Push of 40. So push of 40, before inserting element 40 into the stack, first incrementing the top. So that is top equal to 3. Okay. So now inserting the element 40 into the stack. Okay. So after inserting 10, 20, 30, 40, top equal to 3. So it points to element 40 into the element 40. Top pointer points to the element 40 at the top of the stack. So 4 means, so 0 to 3. This is top equal to 0. This is top equal to 1. This is top equal to 2. And this is top equal to 3. Okay. So now we are performing the delete operation 2 times. So pop operation, first time pop operation is performed. After performing pop operation, so element 40 is removed from the stack. So now the resultant is only, so that is 30, 20, 10. Now top pointer points to this one. Okay. Again we are performing the pop function second time. After performing the pop operation on second time, so the element 30 at the top can be removed from the stack. Now, so 20, 10 is the top points to element 20. So 20 at the top of the stack. So top points to the element 20. So this is the second pop operation and this is the first pop operation. So these are the 4 insert operation. So finally stack contains 2 elements. Finally contains 2 elements. 2 elements, that is 10 and 20. So this is the description about what is the stack and what are the operations performed on the stack and what are the conditions we are followed in the stack and what are the applications of the stack and how to implement the stack and what is the example for stack. So these are the points that we have discussed in this video. So thank you for watching this video. If you like this video, please subscribe my channel and forward the video to your friends, classmates and colleagues. So my channel name is DIVVELA SRINIVASA. DIVVELA SRINIVASA. Thank you.